Okay, welcome. I'm going to try to prepare you as best as I can for this upcoming February integrated algebra regions. Okay, so let's take a look at this problem. It says, what is the value of the expression? And then we have absolute value. These two bars mean absolute value. And basically what they do to a number is that they make the number positive. Whatever comes out of here is going to be positive, regardless of whether it was negative or positive before. It's still going to be positive. So let's see. What is the value of this expression when x is 5? Well, we go here. Remember, this expression is read -5 multiplied by x plus 12. So it's going to be -5 multiplied by the value of x, which in this case is 5, okay? And then plus 12. -5 times 5 is -25 plus 12. -25 plus 12 is -13. So this is equal to -13. Okay, guess what? The absolute value of any number is positive. So unless the negative is outside the absolute value. But since it is inside, then the absolute value of -13 is 13. And that's it. So now, choice number 3 is our answer. Cool, right? Okay, let's continue with this. Question number 2. Oh, by the way, no, hold on a second. Let me show you how to do it on the calculator. Okay? On the calculator, you grab it, and you are going to, I'm going to show you, I'm not going to show you how to save it. I'm just going to show you how to do it. Alpha, window. Oh, let's turn it on first. Okay. So we go to alpha window, and you will see that it says apps. So you press enter, and now you have the absolute value. And now you put the function, which is -5 multiplied by the value of x, which was 5, and then plus 12. And now, my friends, we got our answer, 13. See, it wasn't that difficult, right? Okay, let's move on. The value of the expression negative absolute value of a minus b when a is 7 and b is -3. Okay, so let's set it up first. So the absolute value of, sorry, it gotta be negative. Okay, absolute value of a minus b. All right, let me zoom in just in case. If you could zoom in, there you go. So a is 7. Okay, and then minus b, minus, and then b. b is -3. See that? Some of you might be confused and just write 7 minus 3. No, the minus is from the expression, and b is -3. All right, so negative absolute value. So 7 minus -3. When you have this, just multiply the two signs together and you will get what? Negative times negative is positive. So this is 7 plus 3, which is 10. Now guess what? Whatever comes out of this absolute value is going to be positive, but it's going to be affected by this negative outside. So it says, okay, you're positive, but now you have to multiply me by negative. So then you get -10. Making choice number 1. Choice. Now try it on the calculator. See now. So we press alpha. Okay, clear. Alpha window. You see the apps right there, and we turn it. Oh, by the way, I'm sorry, but outside it had to be negative. So let's do it over. Negative, and then we put alpha window. Enter. Okay. And now we have the absolute value of a minus b. A is 7 minus, the minus is right here. Minus, see that? Minus, and then the negative is right here. So minus, negative, and then what was the value of b? The value of b was -3. Okay, so minus -3. And the answer is -10. Boom. Okay, let's move on to the next problem. Problem number 3. It says, what is the value of the expression? And we have this a to the third power plus b to the 0 power, and the whole thing gets squared. All right, not a problem. So let's write it over here. A is -2, so that will be -2. And look at what I'm gonna do. I'm gonna put the -2 in parentheses to the third power plus b is 4, so plus 4. You see, I'm putting it in parentheses. Make sure you do that so an error doesn't occur, and I will explain to you why the error might occur. All right, and the whole thing, you see that, gets squared. Okay, so -2 to the third power, if you do it on the calculator, you get -8. Okay, now 4 to the 0 power, any number raised to the 0 power is 1. So 4 to the 0 power is 1. The whole thing gets squared. Okay, and now we do the math. -8 plus 1 is -7. So I end up with -7 squared. Now, -7 squared is -7 times -7, which is 49. So your answer is 49, not -49. And of course, let's just put it on the calculator. Okay. So let's see. What am I supposed to put on the calculator? Oh, okay, I got it. So I open parentheses, then I open parentheses again, and I put -2, close it, and this is to raise a number to any power. See? To the right third power. Then you gotta move over. Okay? So we move over and we put what? Plus, then parentheses again, 4 to the 0 power, move over. Okay? Close parentheses again, and you square that. And you get 49. Perfect. See? Calculator at work. Alright then, cool. Let's move on to the next problem. Alright, so now that you got the idea, I'm just gonna set this up. So it's -3 times x squared. Well, x is -4. So -4 squared, you see the -4 goes in parentheses. Okay, times y. So once again, I open parentheses and I put the value of y, which is 2. Plus 4 times x. 4 times x. So 4 times -4. Okay? And now you can just plug that in the calculator and you're gonna get your answer. So let's see. Oh, okay. That should be enough. So -3 times -4 squared, okay, times 2 plus 4 times -4, and you get -112. Cool, right? Okay, this problem, absolute value, whatever comes out of here is going to be positive, right? All right, so let's review the meaning of the word, of the symbol factorial. Okay, all these over 4 factorial. The word factorial, if I have 4 factorial, that just means 4 times 3 times 2 times 1. It's a sequential multiplication. If you have 7 factorial, then that would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, never times 0, because then everything becomes 0. Okay then, so now that I have that, let's have the calculator help us do this. So we already know, let me see now. Okay, like that, yes. So I have to put the factorial first. So you press alpha Windows. I'm sorry, the absolute value. So we put the alpha Windows and you get the absolute value. Now look at this. This is a fraction. So I need to turn everything into a fraction. How do I get that? Easy. Press alpha y equals and then enter. And now you get your fraction. Cool. And now just plug everything in there. All right. So let's see how we do it. 4, okay, times -6 plus 18 over 4. And now let's investigate how to arrive at the factorial. I think you gotta press math and you gotta move to PRB. Sorry, you gotta move to PRB right here. And then there's the factorial. Wow, I still remember. Alright, that's it. I typed my expression and now I hit enter. And guess what? Even the calculator gave it to you in the form of a fraction. So the answer is 1/4. Nice, right? Yes, I know. Alright then, let's move on to the next problem. Now please, if you already know how to do these problems, then do it on your own and just use this as a way to confirm that what you got is right. So if x is -3, what is the value of this? Well, let's see if we could do this by using visual math. So I know this is absolute value, so anything that comes out of here is going to be positive. So let's see, -3. -3 minus 4 is -7. And absolute value of -7 is 7 minus x squared. Well, x is -3 squared. Any number squared is positive. So now I have 7 minus whatever this is, which is 9. Okay, -3 squared is 9. And now 7 minus 9 is -2. Boom. Okay, next problem. Once again, we already seen what factorial means. Factorial is a sequential multiplication. So I cannot stop. I mean, I can, of course. I could write 6 times 5 times 4 times 3 times 2 times 1 plus a fraction 5 times 4 times 3 times 2 times 1 times 3 times 2 you know what, it's a hassle. So that's why I have my favorite friend here. I already showed you how to put the factorial in it, but just in case you forgot, we'll do it again. Okay, so let's clear this out, right? Okay, so let's see now. Yeah, I'll zoom out a little more and see if I can do this. Or I can do this. Yes. Okay, so for factorial, we're gonna press math, right? I'm gonna press this key that reads math. And we're gonna go, oh no, first we need the 6. So it's 6 factorial, 6. And now we press math and move all the way to the right or just once to the left. We have 6 factorial, okay? Plus, now we have a fraction. So let's press alpha y equals, enter. And on top I put 5 factorial. Ay, that's not 5 factorial, oh my god. Nice. Okay, 5 factorial times 3 factorial. Okay, so I got my thingy written already. Let's see what I get. I get 750. So now I get 750. It's multiple choice. Otherwise, if you have to explain something, you could just basically go through the process that you just did, that you just went through on the calculator. Alright, let's see now. This one says, I don't know what it says. Okay, when x is 4, what is the value of this? Well, so x is 4, so this is 2 times 4 to the 0 power plus 4 factorial, because that's what it says. Okay, so we know that anything to the 0 power is 1. Anything. So 2 times 1 is 2. Plus 4 factorial is 4 times 3 times 2 times 1. 4 times 3 is 12. Times 2, 24. Times 1, 24. So 2 plus 24 is 26. Gucci, right? Okay, let's move on. Okay, which property is illustrated by the equation? And we have that. So before we do that, let us go over some properties of real numbers. So that's why I have this, because I'm nice. Okay, so the first property we're going to visit is the identity element of addition. Identity element, okay, of addition. Okay, so the identity element of addition is 0, because anything plus 0 is itself. So in other words, what number, when the identity element added to another number, okay, what is that number that does not affect the original? So if I have the number 3, what number is added to 3 to get 3? 0. What number is added to 10 to get 10? 0. Alright, so now you have an idea of what the next one is. The identity element of multiplication. The identity element of multiplication is 1, because anything times 1 is itself. You know what, let me turn this light off, maybe. Oops, come on. Okay, you could see, right? Yes, because it's better like that, so the camera doesn't do it. Okay. Or maybe I could do the following. Nah, still. No, I'm sorry, I'm just gonna leave it like that. Okay, what else do I need to go over? Oh yeah, additive inverse. Additive inverse of a number, okay. Additive inverse of negative 10 is positive 10, right? Additive inverse of 1/2 is negative 1/2. All right. The other one is the reciprocal, which I call it the multiplicative inverse. Okay, so for example, the multiplicative inverse, or oh my god, that R, awful, or reciprocal, Jesus Christ, or reciprocal of 3/2 is 2/3. Okay, of 5/1 is 1/5. Of this is 5/1, believe it or not, I just put it as 5, but I can always put a 1 under it, and you should automatically understand that it is 1/5. Okay, so if I ask you what is the multiplicative inverse of 10, you say 1/10. What about 1/10? 10, or 10/1. All right, now let's go on to the distributive property. The distributive property, you will recognize it because it only has, two things being added like that. Let me see, AX, then I don't know. Gosh, AX plus AY equals to A times X plus Y. In other words, you distribute, okay? When you use the distributive property, you will see that only has parentheses on one side, just in case you don't know how to use it. If you already know how to use it, then you should be able to identify it. Okay. Now, associative property. Okay, you will recognize there were two associative properties, one for multiplication and one for addition. Let me do the addition one. So it says that whenever you have three numbers, A plus B plus C, right? Whenever you have three numbers, right? It doesn't matter how you group the numbers, okay? I could say A plus B plus C. That should be the same thing as A plus B and then plus C. This property is characterized by having parentheses on both sides. So just remember, but not only that, the property must have the numbers in the same order. You see how I got A, B, C, A, B, C? If they give you an example and ask you which property it is, and they give you a choice as being the associative property, and all of a sudden you see that this is A, B, C, and this is A, C, B, that is not the associative property. Just keep that in mind. If you must, you should rewind this and listen to it 1,000 times until you learn it. Okay then. So for multiplication, it's the same thing. A times B times C is the same thing as A times B times C. Still parentheses on both sides, okay? Then we have the commutative property. Okay. Commutative property. Commutative property says that when you multiply two numbers, the order doesn't matter. A times B is the same thing as B times A. 3 times 2 is the same thing as 2 times 3. 6, right? Okay then. So I think I cover most of the properties. And now let us continue doing our exercises. And you know what? I think I'm gonna move from here because really it's not helping me. It's not helping me for the purposes I want. And now, let me move. I need more space. And here I'm gonna get more space. Yep. Thank you, thank you, thank you, thank you. So let's move on to the next. Okay. Okay, here we go. And now, here, which property is illustrated by the equation? We have that. Parentheses on one side, multiplying, so that's the distributive property. The statement 2 plus 0, 0, we know what 0 is an example of the additive identity, the identity element of addition. Alright, let's move on. Alright, here. A method for solving this, right, this equation is shown below. Identify the property used to obtain each of the two indicated steps. Alright, so here there was the distributive property used. Okay, so distributive property. Okay, and now here it seems like we're combining like terms, but we are not really combining like terms. We are just putting the terms together. Okay, look, this over here. The order really, I could have done it in the same order right here, but they switched the order. So this has to be commutative property. Okay, and nice. All right, let's go on to number 12. Okay, which property is illustrated right there? Let's see. Oh, 3 times 4 is 4 times 3. Oh, commutative property. That was easy. Properties of real numbers. What is the additive inverse of this expression? Well, you have to take each as individual numbers. So what is the additive inverse of A? Negative A. And then what is the additive of negative B? Positive B. So just in case you were thinking that the additive inverse of this is A plus B, it's not true. Think of them as individuals. Okay, perform the indicator operation. Sure, distributive property. Negative 6 times A is negative 6A. And then negative 6 times negative 7 is positive 42. Cool then. Which equation illustrates associative property? Associative property, it has parentheses on both sides. So this one. Parentheses on both sides, but not only that, the order is important. Look, X, Y, Z, X, Y, Z. So that's what I was checking for. Okay, which equation is an example of the associative property of addition? Well, look, parentheses on both sides, but X, Y, 3, X, Y, 3. Don't be fooled by the last one. Look, 3xy and then xy3 is not the same thing. If anything, this could be like the commutative property. Okay? Like 3 plus this and then this plus 3. Okay. Additive identity. The additive identity is 0. So when you add 0 to any number, you get back the same number. Look, you added 0. Okay. Which equation illustrates the multiplicative inverse? Okay, which is the same thing as the reciprocal. So think about it. Take like 15 seconds. Okay, so I hope you got something. Let's see now. A times 1 equals A? No. A times 0 equals 0? No. These are number 1 property, number 0 property. A, what is the multiplicative inverse of A? Well, this is A over 1, so the reciprocal should be 1 over A. Oh, okay. And look at that. Every time you multiply a number and the multiplicative inverse, you always get the identity element, which is 1. Oh my God, I forgot about this. Gosh. Okay, intervals. Interval notation represents the set of all numbers from 2 to 7, through to 7, inclusive. All right, so write this down. Parenthesis means excluded. Okay? Brackets means included. I hope I'm saying it right. Okay? So numbers from 2 through 7 inclusive. From 2, that means that 2 is included. To 7 inclusive. If it says 7 inclusive, that means that I'm gonna use brackets. Okay, I found my answer. Answer is choice number 4. Because I'm good. Alright. Now, what about this? The set of 1, 2, 3, 4, okay, is equivalent to what? Well, think of it this way. Let me go back over here. If you have a less than or a greater than, that is also excluded. If you have a less than or equal to, okay, or a greater than or equal to, that means included, and it makes sense. Or equal to, that includes the number. So let's see what's up here. I need 1, 2, 3, 4. I need to have 1, 2, 3, 4. So basically what this says, 1 less than x less than 4, what this says is that x represents all the numbers between 1 and 4. Now let's see if these numbers, these values are included. So, is 1 included here? No, it's not. So that means that it starts at the next value. It starts at 2. then 3. Then is 4 included here? I don't think so. So it ends at 3. So the numbers here are just 2 and 3. Okay, that's not nice. I need 1, 2, 3, 4. So let's try it here. Is 0 included? No, but we don't need it. What we need is the 1. And guess what? The number after, right after the 0 is 1. So we have 1, 2, 3. Is 4 included? It's not. You see that? But guess what? I need the 4 in my set. So this cannot be the answer. Okay, here. What are the numbers that I have here? Well, let's see. I cannot start at the 0 because it's not included. So I start at 1, 2, 3. And is 4 included? Yes, look, it has the or equal to sign. So 4 is included. Oh my God, so 1, 2, 3, 4. So correct choice is choice number 3. This one doesn't even, 1 is excluded, so it doesn't start at 1. So that's it. All right then. Try this one then. Let's see if you get it. Take 30 seconds. Okay, on the answer? Very good. Choice number 4 is your answer, okay? Because it contains 11 and it contains 12. All right, let's move on to the next one. So all the numbers greater than or equal to 5 and less than 12. Okay, greater than or equal to 5, that has to do with brackets. And less than 12, well, less than 12, that means that the 12 is not included. All right, then you make your choice and that's it. All right, so which set builder notation? This is what you call builder notation, okay? Describes -3, -2, -1, 0, 1, 2. Okay. So let's see now. -3. Is -3 included here? Yes. So we're good for the -3. Now, is 2 included? No. Okay, I can't do that then. -3 included here? No. -3 included here? No. -3 included here? Yes. +2 included? Yes. So it goes from -3 all the way to +2. Hopefully you understand the concept now. Move on. Okay. All real numbers greater than 2. That means that 2 is not included. Anything greater than 2. Less than or equal to 20. Less than or equal to 20. All right? Remember, you can only pass this if you really want to. Okay, so 1, 2, 3. 1 included, yes. 3 included, no. 1 included, yes, because the 0 is the one that is not included. But then I move on to the next number. So it's 1, 2, and 3. Guess what? Answer right here. All right, all the real numbers greater than -6. Greater than -6. And less than or equal to 14. Okay, so now you know your answer, right? Okay, which interval notation describes the set? Okay. Wait. Oh, no, I'm sorry, 27, right? Oh, okay, sorry. Okay, 27, we got, I need the -2 and I need a 3. Okay, I have a -2 here, but I also have a -3, so no, I don't need this. It doesn't, -3 is not included, but then it moves on to -2, -1, 0, 1, 2, 3, and 4. But 4 is included, but I don't need the 4. Oh, okay, so then, well, -2, and I don't have a -4. Nice. I mean, -2, and it does not include the 4, so it stops at 3. Okay, all the numbers Look, is 1 included here? Yes. Is 10? No. So then you're gonna go like this, and then you're gonna go like that. Correct? Inequality can be written as, okay, is -2 included? Yes. Is 3 included? Yes. Beautiful, right? Which interval notation represents -3 less than, okay, once again, here, is -3 included? Yes. Is 3 included? Yes. So now you know your choice. Okay, so now we got 1, 3, 5, 7, 9. Be careful with this number, with this choice. So I need 1, 3, 5, 7, and 9. Look at the first one. 1 is not included. Right away, I cannot have this. Here 1 is included and 9 is included. Look, okay, so this could be a possible answer. Here 1 is not included, so this cannot be our answer. Now here they both included again, but then what's the difference? I mean, come on. Well, it could be 2 or 4, but what makes the difference? Ah, okay. Here they both included and x is a prime number. Prime number. Is this a prime number? No. Is this a prime number? Yes. Prime number? Yes. Prime number? Yes. Prime number? No, because 9 can be divided by 3, by 9, and by 1. So no. Oh, okay. What about choice 4, where x is an odd integers? Are these all odd numbers? Yes. So you see, I wanted to get to this problem, so now you understand that sometimes it's hard. All right. Here. Consider this, okay, complement. Oh my God, complement. Oof. What is complement? Okay, I think I remember. Anything that, let's say we together have the numbers 1 through 5. I got the numbers 1 through 3. So what numbers do you have? 4 and 5, correct? So you got my complement, or I got your complement, because the whole set is 1 through 5. So let's see if we understand this. So consider the set of integers greater than -2. Okay. What is greater than -2? -1, 0, 1, 2, 3, so on. Let's see, where does it stop? And less than 6. Okay. 3, 4, 5. It doesn't say 6. It says less than 6, so I stop at 5. All right. So what is the complement of, sorry, a subset is nothing more than a branch of the main set. So a subset of this is the positive factors of 5. Okay. So let's call this the universal, and let's call this the subset. Okay. Positive factors of 5 are 1 and 5, because 1 times 5 is 5. Those are factors of 5. Nice. So now, what is this subset missing in order to become the whole universal set? Well, that's easy. Let's just cross out whatever we already have. Ah, you like that, right? Of course. So now I got -1, 0, 2, 3, and 4. -1, 0, 2, 3, and 4. Boom. Beautiful, right? If I missed, oh wait. Yeah. 2, 3, and 4. Yes, okay. So just in case, let me see what I got here. Let's move on to the next problem. All right. So the answer is 2, right? 12 players make up a high school team. The jerseys are numbered 1 through 12. Okay, so that's the first thing I'm gonna do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. A subset. The players wearing the jerseys. Okay, so it doesn't say subset, it just says the players. Okay. So this is gonna be my universal set, okay? And I wanna call this a subset. So 3, 6, 7, and 8. Okay, oh, and 11 it says, okay. They are the only players who start the game. Using set notation, list the complement of this subset. Sure, let's just cross out whatever we have. boom, 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 boom. All right, so then what is it that I would be missing? Well, the subset, okay, the complement, and I want to write the word complement, okay, would be what? 1, 2, 4, 5, 9, 10, and 12. That's it. Beautiful, right? All right, let's move on. Okay, here we go. So, given all even integers from 2 to 20, inclusive, so 20 is included, and B is a subset, what is the complement of set B? Sure. Okay, so if I have, okay, I'm gonna start at 2, 4, 6, 8. Look, I don't write the 10, the 12, the 14, the 16, the 18. So the last number is 20. So this is the complement. Answer is number 4. So remember, complement is whatever the subset is missing to become the whole thing. Well, here, well, actually, you know what? You could do this on your own, and we'll talk about it. Complement again. I think I did enough for you to have understood the concept of complement. Let's see what's the answer to this one. Now let's do the answer to this one. Let's go back to 35. So 35 is 4, right? Here we're gonna have to work a little bit because we need to understand what perfect squares are. If you know how to count from 1 through 10, you know what perfect squares are. Let's count from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a perfect square is a number that has two factors of this that are the same number, and when you multiply them, you get the perfect square. Or another way of saying it is a perfect square is a number that can be square rooted. So let's see now. All we gotta do is square each of these numbers, and we're gonna get a list of all the perfect squares. Okay, so 1 square is 4. 1. 2 square is 4. 3 square is 9. 4 square is 16. 5 square is 25. 6 square is 36. 7 square is 49. 8 square is 64. 9 square is 81, sorry. And 10 square is 100. So that's the list. If you cannot say 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100, then at least you could say, okay, 1 square is this, 2 square is that, 3 square is that, blah, blah. Alright? Good. Now let's take a look at the problem. A A is the set of all perfect square integers from 4 to 100. So basically from 4, so it goes like this, from 4 to 100. B is a subset, so they want the complement. Please, let's just cross out whatever we have. We have 16, okay, 36, 49, 64, okay, and now whatever you got left in here, that's the complement. 4, 9, 25, 81, and 100. So the answer to question 38 is choice number 2. Make sure you understand what odd numbers are. All right. So complement. So you could do this on your own. Now you could do this on your own. All right, now let's check the answers. Cool. Okay. So complement, we cross out whatever we have and the rest is our complement. Well, now we're going to talk about intersection. Intersection is everything that we have in common. Okay? So for example, we have set A and set B. What is the intersection of sets A and B? Well, let's see what they have in common. They got this in common. Oh, look, I'm not crossing out anything. This is not like the complement. I am actually matching whatever is the same, okay, on both, because that's the intersection. And it's a way of canceling out too. What else? Do I have anything else? Oh yeah, look, I got 1,8 here and I got 1,8 here. So now I know what the answer is. See that? Okay, so now you understand. Intersection means whatever they have in common. Where do they meet? Here. So Maureen tracks the whatever. Maureen tracks the range of outdoor temperatures over 3 days. She records the following. So, what they want is express the intersection of the three sets as an inequality in terms of temperature T. Sure. Inequality. Okay. Inequality is something that has a less than or equal to. You've been through that. You did it already. I can show you where you did it. See, all these are inequalities. All these are inequalities. Look, inequalities. So don't say you didn't do it. Okay, so let's track. I need to represent the temperatures of the 3 days. All right, so let's see if they intersect. Negative 23. Does any of these have negative 23 in common? No. Negative 20. Does the temperature went down all the way to negative 20? No. 20 here? Yes. I mean, no. What about here? Yes, it went down all the way to negative 23. But unfortunately, it's not common to all 3 days, so no. All right, what about 0? Did the temperature reach 0 degrees right here? Yes, because it went all the way down to negative 20. What about here? Yes, because it went down all the way to negative 23. Oh, okay. So I'm going to write negative. No. I'm going to write 0. Okay, because that's what they have in common. Now let's go over here. What is the temperature that they all have in common? 40. Okay. This one has 45 in common, but this one doesn't, so 40, okay. So the temperature went from the range was from 0 to 40, okay. And it says in terms of temperature T. So watch this. I already have my inequalities set up. I just need the symbols. Well, T is all the numbers between 0 and 40. But guess what? 0 is included here. And 40 is included here. Oh, very nice. Okay. Given these three sets, what is the intersection of sets Q, W, and Z? Okay, so take 10 seconds and then give me the answer. This is not different than what we've been doing. So we have A, B, and C. So they want to know what is the intersection. Well, the intersection, my friends, will be where do all circles meet? Look at this. This is common to, this part is common to this circle and this circle, but not this circle. So figure out what the intersection is. Okay, take a look at this part. This part belongs to this circle. See that? It also belongs to this circle, and it also belongs to this circle right here. So the intersection is 2. Okay, move on. 45, you could do that on your own. Okay, so different topic. Now we're not talking about intersection, now we're talking about union. The union is putting everything together. It's like, hello, when the United States, you know, the Union, the 13 colonies, everything came together. That's exactly what it is. So put everything together. Please remember not to repeat values, okay? Just because you see 6 and 6 doesn't mean that you're gonna repeat the 6 and the 6. No, it's just once. Beautiful. Choice number 4. Okay, 47. This little symbol is a U, so you should assume that it means union. By the way, intersection is represented like that. Okay, but we're not dealing with intersection, we're dealing with union. Beautiful. Okay. So A, B, and C. Then, oh my God, look, I was just talking about it. The intersection of A, B, and C is, what is the intersection of A, B, and C? Exactly. 0. Look, there's a 0 here, there's a 0 here, there's a 0 here. And then there's no other value but the 6. Look, the 6. That's what they have in common. That was intersection. Just make sure you know that. Okay, what statement is false? You should be able to know this. In other words, if they give you this, then you're gonna have to write it down. Okay, the union of A, B, and C is D and all that. So figure it out. Take at least 1 minute. Beautiful. So the answer is 3. Okay, let's go on to number 50 now. If you have questions, then you can just ask, okay? Okay, so given R, what is the intersection of R and P? What is the intersection of R and P? Beautiful, beautiful. Oh, okay. Now, we're gonna start with the next section, which is graphs and statistics, but I am going to take a little break and then I'll come back for another video, okay? All right.